Lewis structures of atoms. Actually, it's more correct to say Lewis symbols. A Lewis symbol has an element symbol, X, with up to 8 dots surrounding it. And the 8 dots are in 4 quadrants. There's the above quadrant, the below quadrant, the quadrant to the right, and the quadrant to the left. And as you fill in these dots, you should put 1 electron in each quadrant before you put 2 electrons in any quadrant. The order of filling electrons in, thus, would be something like this: 1, 2, 3, 4, 5, 6, 7, 8. How do we determine the number of dots? The number of dots is equal to the number of valence electrons. The valence electrons are those in the electron configuration with the highest n value. The electron configuration of group 1 elements ends in ns1, like for instance lithium, which is 1s2, 2s1. So here the valence n value is 2. Therefore, the number of valence electrons in a group 1 element is 1. Group 2 elements have electron configurations that end in ns2, like magnesium, which is 1s2, 2s2, 2p6, 3s2. In this case, n equals 3. But that means there are 2 valence electrons for group 2 elements. Groups 3 through 12 all have electron configurations that end in ns2, n-1 dx, where x is some number between 1 and 10. For instance, iron has the electron configuration of argon, then 4s2, 3d6. In this case, the valence electrons are just the 4s electrons. So, elements in groups 3 through 12 still have 2 valence electrons. Group 13 elements will be ns2, and they may or may not contain a d sublevel at n-1. That'll be d10. Those aren't valence, so we ignore them. And then np1. That means there are 3 valence electrons in group 13 elements. Since the d electrons don't count as valence, we're going to ignore them. Group 14 will have ns2, np2, 4 valence electrons. Group 15 configurations will end in ns2, np3, and have 5 valence electrons. Group 16 will end in ns2, np4, and have 6 valence electrons. Group 17, ns2, np5. 2 plus 5 is 7 valence electrons. Group 18, ns2, np6. 2 plus 6 is 8 valence electrons. Here are the Lewis symbols. A group 1 element has 1 dot. A group 2 element has 2 dots. A group 13 elements has 3 dots, all in different quadrants. A group 14 element has 4 dots, again, all in different quadrants. A group 15 element has 5 dots, 1, 2, 3, 4, 5. And with group 15, this is the first time you see 2 dots in the same quadrant. Group 16. 1, 2, 3, 4, 5, 6. Now we have 2 quadrants with 2 dots. Group 17. 1, 2, 3, 4, 5, 6, 7. And group 18. 1, 2, 3, 4, 5, 6, 7, 8. The reason these quadrants matter is the number of unpaired electrons is equal to the number of covalent bonds possible. We'll call it the bonding capacity.